Okay, in this video, I'm going to talk about bond angles. I know I talked about them before, but I didn't give you the full story. So you may have noticed, you may not have, that when I started putting lone pairs on the atoms in the geometry videos, I didn't talk about the bond angles. Now they're basically the same as the bond angles for the 5 basic shapes, but they change a little bit. So let me give you 3 molecules, and I'll talk about the bond angle. We'll talk about the bond angles in those 3 molecules. Okay. So here's methane, and hopefully you are all thinking to yourself, I know that bond angle, I know that shape. This is tetrahedral, and that bond angle there is 109.5. Okay. Now, same basic shape. We saw that tetrahedral shape, but I'm going to put a lone pair on this guy. Oh, made that kind of big. I guess that's okay for our purposes here, and I'll explain why. Hydrogen, hydrogen, hydrogen. Now we can actually measure these bond angles. I can't, but there are experiments we can do to measure these, and this comes out to about 107 degrees. So there's 4 things there. Oh, and this is just in case you're curious, trigonal, pyramidal. Okay, trigonal, pyramidal. You'll notice that this bond angle is a little bit less than what we would expect, because the basic shape for the ammonia molecule, the NH3 molecule, is tetrahedral. Put the lone pair on there, it becomes trigonal pyramidal. But that lone pair takes up a lot of space. Okay? So what it does is it actually, let's see, it pushes these guys down just a little bit more and makes that angle a little bit smaller than what we would expect it to be. Okay, that's the key here. And now, if we look at water, again, same basic shape. However, this bond angle is even smaller. Okay, and what we find for the bond angle on this bond angle here, that is 104.5. So what's going on there? Well, those lone pairs again, they're big and bulky basically. It seems kind of strange, but they're big and bulky, and they push those hydrogens together even more because there's 2 of them. So in terms of electron repulsion, okay, so lone pair is the greatest repulsion. I'm going to abbreviate that lone pair. So that is the greatest repulsion we can have. Okay, and lone pair, that is more repulsion than lone pair bonding pair. Okay, bonding pairs don't repel, they don't take up quite as much space as the lone pairs. And then a little bit less than that would be bonding pair. Okay, the repulsion between those is the least. So we just write that down here. And one way to think of that would be, let's just make a bond here. Doesn't matter what the bond is. But the reason the bonding pair repulsion isn't very great is because the electron density in a bond is localized between the 2 atoms. But if we have a lone pair, like on that nitrogen or the hydrogen up above, that nitrogen with that lone pair, it takes up a relatively large space. Okay? So it pushes things around more than those electrons in between two atoms, because the electrons between two atoms stay between the two atoms. The electrons that are lone pairs, they tend to kind of roam, I guess, if you want to think of it that way, and they take up more space. Okay, so we can just say a lone pair takes up more space. Lone pair takes more space. And that's more than the bonding pair does. Okay. Now let's look at a similar scenario. I'm going to draw another molecule here. So let's look at this molecule here. And that's formaldehyde. Now, what we would expect to see, we would expect 3 bond angles all at 120 degrees. Okay? But what we find is that these bond angles here are about 121 degrees, and this bond angle is 118. Okay, so what's going on is that the double bond is actually bigger than the single bond. So the double bond, and we're not going to get into that until later in the chapter, but the double bond takes up more space. Okay, so if we go and if we talk about size of these things, first we have a lone pair, that's the biggest. Okay, that is bigger than a triple bond, which is bigger than a double bond, which is bigger than a single bond. Okay, and I think that will do it for that.